Hi everyone, and welcome to this new Cloud Academy webinar. I'm Diego, and I'm in charge of the community at Cloud Academy. Welcome if you're a new listener, and welcome back if you're an existing listener. If you missed one of our webinars, you can rewatch all the previous session at cloudacademy.com/webinars. If anyone wants to send us feedback instead, we have a community forum at cloudacademy.com/community. We mainly talk about content in our community forum, so if you have technical questions, this is the place you need to remember. Today we have a special webinar. I'm thrilled to have David Wells with us from the Serverless Framework family. Hi David, how are you?
Hey, good to be here.
David is a senior software engineer at Serverless, and today he will explore some different use cases for serverless technology with examples from companies and other open source projects. David, it would be great if you could give a quick background of your experience in the industry and how serverless arrived at the point we see today, and then we can go on with the presentation. So I'm gonna hand over to David, and I'll catch you later.
All right, thank you. Cool, so let's get started. So yeah, a little bit of background about myself. As Diego mentioned, I'm David Wells. I'm a developer over at Serverless on the core team of the framework. And I started using serverless technology probably about 9 or 10 months ago. It actually solved the personal pain point of mine, trying to scale out back-end services and a ton of other use cases that we'll go through today. But just a quick look at the agenda. We're going to run through like what exactly serverless is, what it means, clearing up some common misconceptions about it, and then jump into like all of the different use cases. And I wish we had more time than an hour to go through this, but we'll go as fast as we can. Dive into some real-world examples, and then I'm going to show you guys an actual demo of a serverless application that we're going to be open sourcing within the coming week, and then we'll open it up to some Q&A. But cool. So I'm going to jump back here. There's me. Hey, everybody. This is my custom Electron app for sharing my webcam during presentations. But let's dive into what exactly serverless is. So server what? Serverless? Does that mean that there are no servers? Surely that can't be true. There's always a server at the end of the day. This is one of the things that trips people up. They say that serverless is kind of misnamed and should be renamed to something else. But it's kind of the name that is stuck. And it is also, fortunately enough for us, the name of our company. So that's cool. And really, at the end of the day, there are serverless, or there are servers running all the code. It's basically running a compute-on-demand service. And it's really the next evolution in cloud computing. If you think about it, way back in the day, you would actually set up your own machines. Then we went to virtual machines. And then Heroku and all these other platform as a services came out to host applications. Then Docker came out with containers and that additional virtualization layer. And then kind of the next paradigm is serverless. And serverless really at its core means that you don't need to worry about the underlying infrastructure of the code that you're running. It will automatically scale for you and automatically kind of do a lot of things that you would have to manually do with any of the other kind of layers beneath it. But cool. So, and some of the quick benefits of like serverless technology, it's taking a microservices approach. So it's taking an application and breaking it into its smallest pieces, typically individual functions or groups of functions. And you deploy those up. There's a bunch of different places to deploy your individual functions. AWS is probably one of the biggest with their products called AWS Lambda. And really another core concept with like the serverless paradigm is everything is event driven. So that means instead of polling for stuff or having a server sitting around doing nothing, sitting idle. Really, what happens is the compute on demand service Lambda will spin up when there's a request made to it, or let's say a cron job is running, or there's a bunch of use cases we're going to jump into, but you only pay for what you use. So that's why looking at these different levels of abstraction, if you're running a virtual machine or you're running on a platform as a service like Heroku or Docker containers on your own EC2 instances, etc., you're paying hourly for those resources where they might be underutilized, and you kind of have to keep a close eye on that to manage costs. But running through a compute on demand service or functions as a service, FaaS, if you will, kind of gets rid of that. And you only pay per millisecond usage, which is really nice. And this actually spoke to a personal pain point of mine. I had a bunch of side projects and a startup I was working on where I had a bunch of different microservices running on their own boxes that were really underutilized, and I was paying more than I needed to for those individual services. But cool. So, and here are some of the providers of this kind of function as a service compute layers. So we have AWS Lambda, Azure Functions from Microsoft, IBM OpenWhisk, and Google Cloud Functions. So some of the biggest players out there are starting to basically offer these pay on demand, pay per execution, event-driven compute layers, which is really awesome to see. And it's kind of the hot space right now, if you will. But cool, so let's go ahead and dive into some use cases of serverless technology. Everything. You can do everything with serverless. The presentation is over. You can go home. Just kidding. Everything with an asterisk, and we'll get into like why that asterisk is there in a little bit. But really, when you are thinking about doing anything with AWS Lambda, you really can do a lot of things. And this next slide might overwhelm people, but let's actually run through it. And the reason I put all these use cases on one slide, I wanted to basically showcase how many different things you can do and how many different things that you can kind of automate. So let's run through a bunch of these, and I'll dive into a little bit deeper into some examples a little bit later in the presentation. So what can you run on AWS Lambda? Basically any server-side logic that you want, that you don't want like the client to see. So if you're familiar with Node and Express or any of the Python web frameworks for running APIs or Happy.js or whatever, basically you can run any code. Like for most of these examples that I'm going to show are actually JavaScript focused on Node, but you can write in Python or Go or Java. A lot of these different functions as service providers support multiple runtimes, and they're coming out with more and more every day. But yeah, so really the use cases are so vast that it's this presentation again could be weeks and weeks and weeks long. But really think about it as like any server-side logic or making third-party API calls that you couldn't necessarily do on the client. And what I mean by that is like on the front end, if you have secret tokens or API keys or things that you can't run securely on the client, you can push that logic. You typically push it into a server and run it through like an Express app. Again, that Express app though would be running hourly, and you build hourly for that EC2 instance or DigitalOcean box or whatever you may be running on. But instead, you can have that code, deploy it up to AWS Lambda, and have it only run when someone actually calls or hits that API endpoint. And there's a very, very free or very, very generous free tier from AWS. I think it's 1 million invocations a month for free. So if you're running, side projects or even like production apps, you can offload that relatively cheaply or even free to AWS Lambda. So some examples of that is like, let's say you want to send SMS messages to your users with Twilio, or sending an email through a third-party email service like Mailgun or Mandrill. You can basically write a single function that sends an email to a user and leverages these third-party SDKs or libraries to do that. And again, you're only paying, if you pass that free threshold, and I guess whatever the third-party API bills, like Twilio, for example. But yeah, so another example would be form processing. So if you have a contact form on your website, again, you could just set up an API endpoint and listen to those post requests, and then route that form submission through to the correct salesperson, for example. We have image processing. So this is an interesting one, and we'll dive a little bit deeper into this in one of the examples later. But you could basically transform, let's say, so S3, the simple storage service from Amazon, if you're uploading an image to it, that can trigger an event, and you can basically resize an image or convert like a PNG file to a JPEG, or shrink it down, or turn it into a GIF. Like, really, it's up to your imagination, but that's a lot of the use cases that we see, is basically transforming media into different formats. Or like a really common example would be, a user uploads a profile image, and you need to resize that and shrink it down so your bandwidth costs are cheaper. So that's something that typically, any SaaS product would have if they have an account management section. Yeah, so that's a good use case of Lambda. Another one would be web scraping and/or testing. So, and this is another example we'll dive into a little bit deeper. But that jumps into like, basically you can run binary files. So if you wanted to, you could run PhantomJS, or Pandoc is a document converter that converts like Word documents to PDF and a bunch of other formats to binary. But since you have access to Node, and you can run binary files in Node or Java, etc., you can actually run those processes like ad hoc. So for example, if you wanted to, set up a cron job with Lambda and watch your favorite sports, site for their latest scores or latest draft picks or whatever, and then send yourself an email when there's an update, that's an example of something that you could do. Another huge use case is setting up APIs. So back-end APIs for web applications, mobile applications, or Internet of Things applications. So one of the cool offerings from AWS is it's called API Gateway, and basically you can set up your own custom endpoints, and those will route directly to trigger specific Lambda functions. So some of the interesting things you can do there is like you can actually set up a custom authorizer API endpoint with a custom authorizer function, so you can authorize protected API routes. So if you do have, you are running a SaaS, or you have an API that you only want certain people to access, you can basically validate that request before it actually goes and triggers your Lambda function. And some examples we've seen out there in the wild are people implementing GraphQL endpoints, or a single endpoint on a Lambda function that is a GraphQL query to pull in data from multiple sources and throw it back to the client, or breaking down your Express application into tinier functions and running those as well through your specific endpoints. Whew. All right, moving on. So there's also with API Gateway and Lambda, what you can do is actually serve back HTML or binary files, so dynamic images or dynamic SVGs, or you name it. the Lambda function can return that through API gateway. So a good example of this is a lot of our partners at Serverless, they will form marketing campaigns where it's really spiky traffic. They'll create marketing pages through API gateway, and Lambda will basically dynamically generate the page and serve back the HTML to that person, and they don't really need to worry about scaling those instances because AWS handles all that for you under the hood, which is really cool and something that it's non-trivial to do. Another good example, another good use case is webhook listeners, and this is actually one of the demos that I'm going to show at the end, where if you wanted to listen to any third-party service that's triggering post webhooks out there, you can set up a Lambda listener, and again, you're not paying hourly for a box running. So this enables a lot of really cool applications to be run and set up with really little to no cost to the actual companies. And the example we're going to run through in a little bit is the using GitHub webhooks. But all kinds of SaaS products offer webhooks these days. And setting up and maintaining a server just to listen to those webhooks is a little bit more than we'd like to deal with. So, and we'll run through that in a little bit. Another use case would be running cron jobs. So again, like if you don't want to set up your own server and pay hourly for that server, that may be running a cron job, once a day or once a week or what have you. You can do that through AWS Lambda, and you're only paying when it actually runs. So this enables a lot of really cool things, a lot of really cool automation. For example, you could set up a cron job, like I mentioned, to run a PhantomJS process to go, scrape your favorite website and pull back the latest information and send yourself an email with that. That's, you can really mix and match all of these things together, which is what makes kind of this serverless event-driven computing really powerful, in my opinion. Another use case would be DevOps and infrastructure automation. So what I mean by this is you can set up events based off of your infrastructure. So let's say that your team is deploying EC2 instances and they don't have the correct certs, or there's things that aren't quite right about it. You can do basically like running a cron job or through CloudWatch alerts, trigger a Lambda function to make sure that everything is in compliance. If not, then automatically spin down that EC2 instance or send yourself a PagerDuty notification, or use your imagination. You can do a lot of things there. And there's a good tweet that was sent in as a use case of this, which I'll jump into on that. I think it's the next slide. So one of the reasons why there's a star on everything is this one right here. So there is a limitation with running code on Lambda, and the limitation right now is you can only run a Lambda function for a maximum of 5 minutes. So if you do have processes that run longer than 5 minutes, Lambda might not be the best thing to run that process-heavy thing on. But that's not to say that you couldn't automate that process. So when that long process needs to run, you could trigger a Lambda function to automatically spin up your EC2 instance, have the EC2 instance handle that really long-running job, and then pass it back to a Lambda function to store it in like an S3 bucket or whatever. It's, again, up to your imagination what you can use there, but that's an example of basically infrastructure automation that can kind of supersede some of the limitations of running a Lambda function. Another kind of workaround, as a quick aside to running a longer process, is you can have a Lambda function recursively call itself. You want to be careful of doing stuff like that because you could run into an infinite loop. But yeah, so it is possible to kind of chain Lambdas together to run them longer. But if you're doing things in that way, your architecture probably isn't event-driven, and you might want to revisit like how that architecture was designed. There's probably something that you could fix there. Like I mentioned, auditing resources for security kind of goes into the DevOps automation thing as well, where if you want to make sure that everything is kosher inside of your AWS account, you can basically set up those cron jobs to watch stuff or react to infrastructure events. And infrastructure events is interesting because basically AWS, they actually, everything that they created for Amazon.com to like drive that their main business. But a lot of their infrastructure is event-driven, meaning when something happens, like for example, a new file is uploaded to S3, or a new row is added to a DynamoDB table, or like a certain event happens in AWS, like a new EC2 instance is spun up or what have you, they basically send out events to any Lambda that may be listening, and you can react to those. You can also chain those together, which makes it pretty interesting to do kind of like data processing and what have you. But yeah, so and there's a huge list of all the infrastructure events that AWS provides. These are just some of them. So a really good example of this would be like, okay, so with DynamoDB, if let's say a new user gets added to your users table in DynamoDB, that can then trigger a Lambda function to send an email to that new user, welcome them to your service. So before this kind of event-driven paradigm, you would need to wire up kind of all that logic yourself, but you get that out of the box with basically everything being an event and triggering another event. It's a very natural kind of way to think about your application rather than writing a bunch of logic around that in a kind of a more monolithic application. Another kind of use case of AWS Lambda is writing your own custom Alexa skills. So if you do have an Amazon Echo, you can basically write your own custom commands and say, hey Alexa, when is the next bus coming to my neighborhood? Or hey Alexa, what's my stock price of XYZ? Or you could say, use an Alexa skill to trigger any one of your kind of Lambda functions that you set up to go do something and then return you back that voice, data basically. Which is pretty interesting. Not necessarily. I guess there are some business applications of that, but it's more of kind of a weekend hobby type of thing. And then we also have IoT events. So if you do have smart devices, or you're building like custom Arduino, bots and what have you, you can trigger Lambda functions from those, and that's actually one of their newest offerings that they announced at Reinvent this year. And then another like really big use case that we see is creating bots, chat or voice bots, voice being the Alexa or Lex, and then like bots like a Facebook Messenger bot, a Slack bot, et cetera, et cetera. Yeah, so that's just some of the things that you can do. And again, all of these pieces can be mixed and matched together. So it's really, that's really why I say everything, except if you're doing something that, the process needs to run longer than 5 minutes. In my experience, I haven't had too many of those things that need to run more than 5 minutes. And if I do have something that's running 5 minutes, I've done something wrong with my code. But there are a lot of like machine learning and big data type things that do need that kind of longer process. So just be cognizant of that limitation. And then a couple of examples that got tweeted into me yesterday when I asked on Twitter. Robert Taylor, this is a simple but really helpful one, checking the SSL expiry on a CloudFront SSL endpoint. So this is, again, that DevOps automation component. So like, hey, if this thing is close to expiring, send me an email so we can renew it and we don't have problems, which is interesting. And then he also tweeted in a function. Basically, this is about restoring an S3 object to a specific point in time. So if something gets messed up or someone overwrites something in a S3 bucket and you want to restore that to a point in time, you can do that. And then Kevin Old, this is one of our community heroes, I'd say. He's using AWS Lambda to capture SNS events and process them to a DynamoDB table. So if you have a really high throughput application and you want to basically queue up those events coming in, so you don't basically throttle your database, because Dynamo, you have to set a threshold of how many writes per second you're expecting and kind of manage that. You can basically throw that stuff onto a queue first, and then as like Dynamo's ready, it can process it. So it's a good way to alleviate some of those bottlenecks with stuff. And then John McKim also tweeted me this one, which is pretty hilarious. So I asked what are some of the best use cases for using Lambda, and he said replacing people's faces with emojis. And so then I followed the link. This is on Hacker Noon. Highly recommend checking it out. But what he's doing here is pretty interesting, and I like the diagram as well. Basically, this is illustrating kind of that event-driven paradigm where we have an S3 bucket that a user is uploading an image to. The onCreated event fires from that bucket. So like, hey, a new file has been created. It triggers a Lambda function. That Lambda function then uses another AWS service called recognition to do facial recognition, and then put emojis on people's faces. Silly use case, but you can imagine, changing out this. Instead of putting an emoji on someone's face, you could, do all kinds of image processing to make your application smarter with a very, very simple kind of flow here, and one that's pretty easy to follow with not a lot of logic written. So very interesting use case, but kind of illustrates like how you could do a media processing pipeline relatively easily. Another example, this was a blog post on the Serverless blog, how to build a screenshot service with AWS Lambda, and this Sander DeGraaf contributed this post, so thanks, Sander. But basically, this one is about how he used PhantomJS, which is, those of you not familiar, is a headless browser, which means it's just like basically Chrome without an actual UI. So you can run it as a binary file, give it commands, and it will do your bidding for you. And one of those things that it can do is take screenshots. So he is using a couple of different Lambda functions here, like one to create a screenshot, one to list screenshots, and one to create thumbnails of those screenshots. And yeah, it's pretty interesting. I like this one personally because it's illustrating how to use a binary in Lambda. So in a Lambda function, if you're writing in JavaScript, you have access to everything that is on the npm registry. So all these third-party modules that people have already written and contributed. But you also, can run those binaries. Again, this works in all the other languages as well. but I'm a JavaScript developer at heart, so cool. So recommend checking out that example on our blog. It's pretty interesting. Here's another use case, which is pretty common. So let's say that you did want to refactor your application's code, and you wanted to basically protect certain API endpoints. So like, okay, only if this person is a paying user can they use this premium feature, which is extremely common if you're building any kind of application. And this diagram demonstrates how that kind of works. So let's actually go to this demo real quick. So this is a live demo. So Auth0, serverless, protected routes. I'll tweet out a link after the webinar. But basically, this demonstrates like there's a public API. So I just called out to our public API. Let me see if I'm console.logging this. Yeah. So this is doing a network request. So I have a API endpoint set up that anybody can access. And then I have a private one that only people that log in can access. So for authentication in this case, we're using Auth0, which is a super handy auth tool. Amazon also has one called Cognito, but I just auth via GitHub, and now I can actually call that protected API endpoint. So that's cool. The source is also on GitHub. Yeah, and this is a good time to call out. So if you're looking for examples of code, and this is using the serverless framework to deploy to AWS Lambda, and we have some OpenWhisk examples in here as well. But this is the AWS Node Auth0 custom authorizer, where basically it's using that custom authorizer function right here to check a JSON web token that's provided from Auth0's authentication service. If the JWT is correct, then we go ahead and pass them along to our protected API and then return the response. If they're not, we return a not authorized back to the UI. So that's like a very common use case. And this one thing to point out, what's cool about this is like this authorizer function can be attached to all of your API endpoints, pointing to any given function. So you don't have to recreate or reuse your auth logic in all of your functions. You can kind of just have this one in the middle to handle all the auth for different functions or aka endpoints. So that one's pretty interesting as well. So let me jump back into the presentation. Yeah, so that's some of the use cases and examples. Let's see how we're doing on time. All right, cool. So I did want to call out, so if you are looking for additional examples, like I mentioned, we have the serverless examples repository. There's a ton of different examples, like how to do a REST API and connect it to DynamoDB, how to set up that cron job, how to do an Alexa skill, how to set up a webhook listener, etc. How to use environment variables. Check out, our examples repo, and for like more projects out there, if you actually scroll down in the README, we have a ton of people from the serverless community contributing examples of basically different applications that they've built. So you can go ahead and check out the source for those and see how they're actually building these more complex applications with AWS Lambda, and they're deploying with the serverless framework, which is really cool to see and pretty awesome. So yeah, and that was one of the hardest things jumping into this like 9 months ago for me was okay, so if you have if you already have microservices and then you need to break them down even tinier, how do you manage that? And that's really like how I discovered the serverless framework. and how like I basically organize all of my applications now. Another good resource for finding different examples, this is like a GitHub pro tip. If you actually go into GitHub and search for .serverless, so this is a hidden file that people get ignore from their serverless projects. But if you search for that and then search for recently indexed or recently updated, oops, I'm actually in this repository. Let me go back. Search. And then just go recently updated. So I can basically, this is just like I do this all the time to see what people are building out there. But there's a ton of really awesome examples of people doing interesting things with serverless. So highly recommend doing that search and digging around, seeing what you find. If you find something cool, tweet it at us and let us know. Because it's always interesting to see how people are architecting their different application and use case. And I already mentioned the examples repository. So let's actually look at like some real world use cases and like users. So this isn't just like for hobbyists. Tons and tons of enterprise organizations are adopting Lambda at a pretty rapid pace, mainly because of the cost savings associated with it, and just kind of this new event-driven paradigm of it's just a little bit, in my opinion, easier to understand. And when you take this microservices approach, it also kind of gives your teams more autonomy. So, one team can be working on their microservice and their functions and deploy those individually of the rest of your application, which allows you to be much more agile and quick to market with new features and new products. But some of our users of the serverless framework, so Nordstrom, they're a contributor. They're a big retailer in America. They have like over 200 functions in production today, and they're using it for some of their web backends, some DevOps automation, and for streaming data processing as well. And then Coca-Cola is also a big user of the framework. They're using it for some API backends, web and mobile. Yeah, there's a huge list of companies doing this. So it's not just for the hacker hobbyist out there. Big companies are adopting it. And just a quick shout out, if you haven't seen the presentations from AWS Reinvent, which is their big conference every year, I highly recommend checking out. They have a serverless playlist. This is a link to the video from Tim Wagner giving kind of the state of the union of kind of where serverless technology is going, and he really illustrates a lot of the cool things that people are doing, and there's some live kind of case studies as well. And one of those was FINRA, like the financial, what is it called? The Financial Institute of something. I got to look that up. But basically, they're processing like billions and billions of events. They do financial regulation for the stock market and what have you. This is a government agency in America. But in the State of the Union address, he kind of goes into all of their different use cases. It's really interesting to see like how many events that they're processing on a daily basis and how they're using Lambda to do that. Again, because they're using Lambda to do that or function as a service provider, they don't need to worry about container orchestration and making sure like their system is up and resilient. It's all kind of abstracted away from them so they can focus on kind of their core business logic rather than on that kind of DevOps piece. A couple more quick examples. So Accenture's using Accenture's using it to build large backends. And we also, like I mentioned before, some of our agency partners, they're using these for kind of marketing landing pages as well, just because you get that raw scale out of the box. If you do need a dynamic kind of HTML based off given parameters or what have you. Yeah, Coca-Cola is also using it for marketing pages. Servata is an interesting use case. They are using AWS Lambda so it's a survey company. If you see an ad and you go to another property that their JavaScript is running on, they'll pop open a survey to basically test ad effectiveness. And they're using Lambda to process like billions of requests to basically cookie the people that are seeing their ads so they know what survey to send them. They also have a case study on AWS's site and a video from I think it was Lambda Day last year here in San Francisco. I think that's online. I'll look for a link after the webinar. And Nordstrom, again, like they're doing some really cool stuff. They're also they have a project. Let me actually pull that up just to show you guys. Nordstrom. So they have a product called Nordstrom. What is it? Artillery. Yeah. So they have a project called Artillery, and it's basically doing load testing with Lambda. So one of the things that is pretty interesting about Lambda is, so it's not like if you're calling a single server, you could be blocking that, and if you write it the wrong way. But with Lambda, you can spin up parallel processes. So you could basically spin up a bunch of workers to like load test a specific service or a specific like site, and that's what this Artillery project is all about. Kind of hammering and battle testing your services before you actually roll them out to the public. So that's pretty interesting. Another cool example of kind of this idea of parallel processing, like spinning up not just one Lambda to do something, but like a bunch of them, is Netflix. So when a new movie is uploaded to Netflix, they will break that file into tiny chunks, and then basically take all those tiny chunks of that single file and then spin up all these different parallel lambdas to do the encoding and then put it back together. So you can actually, because you can kind of fan out into an infinite number, infinite with an asterisk number of lambdas running concurrently, you can do a lot of interesting things there in terms of speeding up things that might have taken a long time historically. But cool. All right, so that was a lot. We have about 15 minutes left, so I'm going to jump into the demo real quick. So this is the event-driven GitHub status board that we're going to be open sourcing early next week. For basically every open source project can use this and deploy it and use it for your repository. This is what it looks like. The UI is customizable, the color scheme and what have you. But basically what it's doing, it kind of is taking the GitHub project approach but automating it. So this pulls in all of the open issues and PRs and puts them into categories of our choosing. So we can kind of check the status of the serverless framework and keep tabs on kind of where things are, and we can sort based off comments and recency and what have you. This is the project. Let's actually look at some of the specs. So the way that it works is there's two services. There's a GitHub webhook listener. So this is what it looks like. So basically, inside of our GitHub repository, let's say a user comments on an issue or submits a pull request or comments on a pull request, basically any activity we want to know about, that triggers a GitHub webhook, which is something they offer out of the box, which is really awesome. That triggers an API gateway endpoint and posts that data, whatever just happened. Our Lambda function is sitting there waiting, but it's not running. That's an important distinction to remember. It's not running, so we're not paying hourly for it. We only pay when it runs, and that's only if we're surpassing that million invocations a month threshold, which I don't know of any GitHub repository that does that, and if you do, wow, that's a popular project. And then it saves it into a DynamoDB table. So that's the back end of the service. And then for the UI, it's basically the user comes into the status board. They see it triggers an AJAX request, which goes through API gateway, triggers a Lambda function to basically pull the items back from Dynamo, and then that sends it back and populates the UI. And the UI is just a React application. Yeah, and so we'll be open sourcing this shortly. Let me actually show you guys some of the code, how this actually works. So, the back end is basically our GitHub listener and our let's see. So, sorry, I just saw a message. Okay, so the back end is basically we have a couple of handlers, and this is kind of the signature of a Lambda function. So there's an event, context, and a callback. But basically, it's just a simple node function that I'm pulling in some modules from, I guess this is core node, and this is actually pulling in from NPM, so I'm using a third-party dependency there. But this is the function that listens for any request coming in, and then I have some functions that actually go and scan the database for items and what have you. And the way that we define this might look a little bit confusing, but basically in serverless.yaml, this is actually where I define my my service name, whatever it's called. This is the status port. I'm using variables here. You don't need to use variables. Like I could just call this like webinar status board or whatever. I'm using variables. Our variable syntax is in our docs. I'm using variables so everyone can use this project once we release it next week. But basically, let's actually do a live demo. So, live demo time. Okay. So, SLS. So, SLS is short for serverless. If you haven't installed serverless, you can do it with npm I serverless-g. But I'm going to run the serverless deploy command. And what that's going to do is basically start creating a stack, a CloudFormation stack for me. While that's happening, because it does take a little bit of time because the IAM creation from AWS is a little bit slower than I'd like it to be. So while that's creating, let's walk through some more of this. So in our serverless.yaml, we specify like where we actually want to deploy this code to. So in this case, we're deploying it to AWS. The runtime is Node.js. You specify a region and a stage. So the region and stage here, I'm just pulling from my config file. So I'm deploying this to the West region, and I have a couple of secrets that is also being used in here. I'm defining some environment variables. So with GitHub webhooks, you give it a secret like token or just text, whatever you want, and that is basically your code will validate. So inside of my Lambda function, I have the process.env, whatever I'm defining. So that's what that is. And then I'm also defining some permissions for the function. The Lambda function needs the correct permissions to access the database and get the items back for the UI. So this is just an example where I'm basically saying like allow this Lambda function to access Dynamo these commands and this is just specifying the exact database that we're creating. Let's see. Okay, cool. So the deploy finished. So let's look at that real quick. So what we've just done is created a new service in AWS, and it's created a couple of endpoints for us. So we have a post input endpoint. This is actually what I would plug into GitHub webhooks. There'll be a tutorial video on how to kind of set this up when we release it next week. And then there's two endpoints for getting the actual items. So there's open and closed issues in this example. Let's actually go and look inside of AWS real quick. So here's actually my two databases that were just created. Webinar prod, closed items, webinar prod, open items. So you can see basically like with my serverless.yaml, I'm creating the resources like automatically and wiring up all the endpoints kind of automatically, which is pretty cool. And the functions defined are just these three. So that's the function that I showed you guys a little bit earlier, the webhook listener. It's listening to an API endpoint HTTP event. The path is /webhook, and it's a post. So that's basically what this URL is. And these are also kind of live get endpoints, which are defined right there. And then down at the bottom, this is actually the table that I'm creating. So there's two, and this is straight CloudFormation if you're familiar with AWS CloudFormation. But basically, I'm saying like, okay, give me two tables. One's called open issues, one's called closed issues, and then it just defines the key schema, the hash and range key. But that is basically the setup. Yeah, and we just deployed that live. And now, like, if I just deployed the front end, all I need to do is plug in these get endpoints to my front end code, so it knows where to query for the items, and plug in this post endpoint to GitHub webhooks. So every time something happens, it posts to the database. That's pretty much it, and that's basically what drives our roadmap, or aka status board. So yeah, so that is the quick demo, and yeah, this will be released probably Tuesday of next week. I'm going to Mexico tomorrow, but when I'm back, we'll release it. And yeah, so I guess we have a couple minutes left. Let's see if there's any questions. Somebody asked, so there's no need for auto-scaling or elastic load balancing. So yeah, no, there isn't. So API Gateway and Lambda under the hood will do all of the auto-scaling for you. You don't need to worry about it. There's only one limitation there, where if you have more than 100 concurrent Lambda functions running at once, that's kind of the account limit. That limit can get lifted, though, if you're hitting it, if you contact your AWS kind of support rep, and they will lift that limit because you're giving them money, and they want that. Okay, let's see. So there's another question. You don't need CloudFormation to create AWS resources. So you do, yeah, if you're creating certain resources, you do need to define those in the resources section. Some things will be created for you, though. For example, just by defining the HTTP event here, this will automatically create the API Gateway endpoint and the Lambda function for you. So you don't need to define that in CloudFormation. You can just do that by defining specific events. And there's a ton of events. Let's actually look at the docs. So serverless.com/framework/docs. There's a bunch of events right now that you can basically listen to. And these are examples of how to basically use those. So in my functions, this is a resize example. So I have a function in a file called resize, and the function name is handler. And if any event happens in this bucket called photos, basically trigger this function. So you can kind of check out the docs. Another good example is the cron job. So in my functions, if I wanted to add this in here, let's go ahead and do that as an example. So if I wanted to add in a new function, so I'm adding in a new function called crawl. Let's just pretend I had a file called crawl.js. That's what this is referencing. And I'm setting up an event. So I want this to run every 2 hours, this function crawl to run every 2 hours. Or I can't remember what this syntax is saying, but I think it's every 12 hours. So you can set up cron jobs, listen to Dynamo events, IoT events, etc. Let's see. Can I use Lambda for running DynamoDB? No, you would spin up, so with this is MongoDB. Can I use Lambda for running MongoDB? No, because that would be a process that you'd always want running. So in that case, you would want to spin up your own EC2 instance or use Amazon has a couple managed database services that aren't Dynamo. But yeah, so for running your own stuff, you would need to host your own server for running that Mongo. So you would need to worry about kind of the scaling side if you were trying to use MongoDB. Dynamo is kind of weird at first, but it's super powerful. And it's Amazon's NoSQL kind of Mongo equivalent with a slightly different kind of API for interacting with it. Let's see. This is a good question. So what would be the steps to migrate an existing application to serverless? So I would say start with something small. So if you have some process or some DevOps thing or just anything tiny that you can shut down that server and just put it into a Lambda function, just try it out. As you start to get the hang of it, you can start to break down your application into smaller and smaller chunks. And there are some projects out there to kind of port over. Let's say you have a Node.js Express app. There are some projects that kind of will port that over to a Lambda-like environment for you. I think it's actually from AWS. So just search for AWS like Express Lambda. But yeah, so it's really just like breaking up your existing application into the core kind of segregated pieces. So like, oh, the billing happens here, account management happens here, whatever API happens here. So like breaking it up into smaller pieces, and then basically having the flexibility to deploy those independently. Really good. I'd recommend reading Microservices. It's an O'Reilly book. Came out last year, but it's basically talking about how you would break down a monolithic application into tinier chunks. Let's see. Question. Does the CloudFormation stack create the API gateway for Lambda scripts? The framework does that for you. So if you're, and the framework's free to use too, like we're, not charging money for any of that. So you can go into the AWS console and, create Lambda functions, upload zip files, and what have you. It's rather painful though. So I highly recommend using a framework to do that. It'll automate a lot of that stuff. Same with API Gateway. Like wiring up those endpoints manually is really not fun. So yeah. Um, and man, there are a lot of questions. So I'm trying to implement a serverless web application using AWS. How can I implement SSL in a serverless architecture using Let's Encrypt? So the same way that you would mask a URL with any other service and put an SSL cert, it's the same process. We use Cloud, what is it called? Route 53 for our kind of DNS stuff. Let's see. Oh, man.
Yeah, David, I have a question for you.
Yeah, sure.
So you mentioned that you went to the Reinvent, right?
I didn't get to go, but I watched all the videos.
All right. So out of curiosity, what was your favorite thing in-house at the Reinvent this year?
Let's see. My favorite thing that they announced was the step functions. So there actually was a question related to like state. So because Lambda functions basically can only run for 5 minutes and there's no state, they're stateless functions. So you can't really store a variable in there and like call it reliably. So that's actually one of the things that step functions kind of tries to solve, where you can basically chain together a bunch of different Lambda functions and pass state between them. And the way that they're doing that is with basically you write out the step function flow in a JSON format, and then you can see in their UI how your actual application is running. Let's see, AWS step functions. So that was pretty cool because that was one of the biggest challenges, is like, where do you store state and how do you like visualize it? Yeah, and here's an image of that. So like you can basically see exactly how your application is working and how it's flowing just by defining it in this JSON like syntax, and they give you a UI on top of it. And then when you actually trigger it, if there's any error through any of the steps, it'll like highlight in red. It's just like an easier way to visualize your system, because when you break it down into such tiny pieces, so microservices were one thing, but now it's like microservices, if you will, with like the individual functions. So kind of maintaining that mental model in your head can be challenging, and step functions was like one of the answers to do that. They also have a tracing application that they launched, or I think it's coming for Lambda soon, but they announced it at reInvent, where basically you can trace how the infrastructure is interacting with each other and kind of map that out as well. So that was what was cool to me, is basically seeing step functions.
Wow, great.
Yeah.
So I think that we are running a little bit out of time right now. So I'd like to thank you, David, for taking the time today. It's been really good talking to you and listening to what Serverless is building. I hope we'll have other sessions together in the future, and I invite you guys to keep an eye on us for updates. We might organize something like an office hour together or something like that in the future, because we're receiving so many questions, so we'll try to answer all of them in our community forum at cloudacademy.com/community. I hope you enjoyed the live session, and if you have feedback or additional questions, please reach us out with your suggestions. Thank you, David. I hope you enjoyed the session.
Thanks
too.
For having me. Yeah, if you guys have any questions, feel free to tweet at me at David Wells or at Go Serverless on Twitter. And yeah, we love to see what people are building out there with this kind of new serverless kind of paradigm. So yeah, let us know.
Thank you, David. Diego here. Until next time, keep up on building amazing things on the cloud. Thank you, guys. Thank you, David.
Thanks.